Welcome to Circuit Fix. Today on the bench I have a DynoCom Dyno. The customer says that the wheel speed sensor does not work, so let's crack this thing open and have a look inside. So the customer sent in this DynoCom control unit, the DC J-Box, and the handheld controller, along with the power supply and a few connecting cables. Let's go ahead and connect everything together. The hand controller has a DB9 that plugs into the front of this. There's a DB25 connection cable that goes between this box and the J-Box. And this is a 12-volt power supply. And the last thing the customer sent is this wheel speed encoder that tracks the speed of the wheels of the vehicle. That will plug into the J-Box here. Now I'm going to power the unit on. Let's take a closer look here. When this spins, the RPM should show up on the screen, and we have nothing. Let's go ahead and open up this J-Box that receives the information from the encoder. I assume there's an issue inside here. We need to find that. All right, here we go with our trusty Amazon Basics electric screwdriver. I love this thing. It was very inexpensive. And I'll tell you what, it's got a lot of torque for something this size, marked 4 volts. Charges right up with a USB-C, and I love it. Maybe I'll leave a link in the description underneath this video. You can get your very own Amazon Basics electric screwdriver. This should lift right off. We have our input here from our encoder. This looks like a DAC chip of some sort. And some shift registers. This is fairly basic. Let's go ahead and sort of follow our traces under the microscope. And I'll inject a signal where the encoder goes and see if we can find out where that signal gets dropped. Now I've connected my scope probe to where the encoder comes in. And if we spin the encoder, you can see on the scope up there, the duty cycle changes the faster I spin it. But we do have a signal coming in there. So let's poke around and see if we can find the signal on any of these chips, especially the input side. Maybe we can narrow it down and find a bad chip. Nothing. Whoop. No. There's something. Okay. We found the signal here at least. This is pretty far into the circuit. So there's our signal. Yeah, definitely the signal. Let's see if it's on any of the output legs. Okay, that's probably our power pin. Let's go ahead and check out a data sheet for this chip and see what it's doing. This is a differential line driver and receiver pair, which makes sense. Let's look at the pin out. Okay, yeah, pin 1 is the voltage. Looks like it should be around 5 volts. Like I said, we could see the signal here on the input, but nothing on the output, and that should be on pin 2. And there was nothing there, so safe to say there's something wrong with this chip. And our scope showed a DC voltage on pin 5, so something's wrong here. So let's see if we can find a replacement chip. I'm going to check my inventory very quickly just to make sure I don't have any of these in stock somewhere. And would you believe it, I do. I've got 9 of them. Let me go grab one of those really quickly. And I was able to find the new chip. Let's go ahead and replace the faulty one with this. This should be pretty straightforward. We've got our pin 1 in the upper right hand corner. I'm just going to come in here with some regular old pliers and just kind of gently pick up on it, and that came out very easily. And then make sure that the legs are straight on our new one. I think we can reasonably get this in the socket. All right, that's looking good. Very good. Now that we have the new IC installed, the moment of truth. I'm going to clip the scope probes back on where we had them earlier. And I'm going to probe the lead on the chip that should be the output. Now I'm going to spin this encoder, and you should be able to see on the scope the duty cycle and the RPM on the handheld here if the repair worked. 3, 2, 1. Yes! We got it. We have picture. If you enjoyed this content, please like and subscribe, and I'll see you next time. Circuit fixed.